Hello everyone, welcome to the GeekNarrator podcast. I am your host Keval Yapte. Today I am joined by Pratik Pandey, who is working as a senior software engineer at Booking.com, and he has vast experience in the industry, in the software industry. In this episode, we are going to touch everything about system design, and not just interviews, but beyond that, how system is designed in real world, how it differs with an interview, what are the things that you can do to get better at system design. And at the end, we'll also share some resources to understand how to get better at system design, how to prepare for interviews, and what are the key differences, and how to keep learning on that track. So with this, Pratik, let's start with a brief introduction.
Sure. Thank you so much, Cavalier, for having me. So I'm Pratik. I have around 9 years of experience. And I'm currently working as a senior software engineer at Booking. I joined just last week, so not much to share there. Before this, I was working as a principal engineer at Associum. Mostly throughout my career, I've worked on big data, batch and stream processing systems. Early part of my career was more into web development, but over the last few years, it's been concentrated with dealing with a lot of data and basically designing stream or batch-based solutions. So that's at a high level about me.
Awesome. So before we jump right into the episode and discuss everything about system design, I want to put out some disclaimers here, right? So there are so many myths around system design and specifically around system design interviews, and so I believe that there is no perfect system design. There is always some improvements that we can do in a particular system design or an application. And whatever design we come up with for a system, even in real world and interviews, it's based on some choices that we have to make. And those choices are driven by so many other parameters and inputs that we take from, so many different things. So there's not just one angle to look at system design, but there are so many different angles. And it's just about getting better at looking at a system design from different perspectives and making the right choice given that context, right? So that is the disclaimer. So don't take it as like perfect thing. Keep improving, keep learning more on system design, and you will eventually get better. Other thing is, so I am not an expert in system design, right? And we just have, experience designing systems for real world applications and also taking interviews and giving interviews. So whatever we are going to share is basically a digest of our experience of taking interviews, giving interviews, designing applications, and not impacting the customer. So this is what we are going to share today. So with this, do you want to add something, Pratik, or it's
I completely agree. Whatever we are sharing is based on our experience.
Exactly.
No guiding light, or basically it can be leveraged as a guiding light, but it's not a foolproof, perfect answer to everything.
Yeah. So we'll try to, destroy some of the myths that are there around system design and give it a very realistic flavor, and not just for the interviews where you just cram some things, you just try to spit it out in the interview and try to, crack interviews. So it's not just about interviews. It's more about system design and how do we make those choices to design a better system. Great. So in the first section, let's dive deep into, real world system design, because that's what really matters. And that goes a long way.
Yeah.
So if we have to design a framework. So again, this is not one framework to follow, but this is one of many frameworks you can follow to, get better at system design and make right choices. So how do we go about designing such a framework, or like a checklist to follow when we look at any problem and try to come up with a design for that solution?
Sure. So I'll start off with some basic checklist that we could have just to ensure that we are covering most of the basic requirements. So we'll obviously start off with requirements gathering. And here we split requirement gathering into two parts. One could be functional and the other one could be non-functional. Mm-hmm. In the real world, the biggest challenge, according to me, is having complex requirements. And the reason why there is complex requirement is because you're trying to deliver something that could impact a customer. And a customer is anyone who uses your product. It doesn't mean that there's an end user. It could be a developer. It could be a product manager. It could be anyone who you're designing the system for.
Yeah.
And because you're designing for a person and a person has different choices, the system becomes automatically complex.
Yeah.
So while designing good systems, you want to keep a track of all the major functional requirements such that you know what your system should be built for. Like what are the major capabilities that your system should have.
Yeah.
The other part on the other side is the non-functional requirement. And this is where our NFRs like scalability, availability, resilience, fault tolerance, like all of these things come into the picture. And this is more from the constraints that you want your system to abide by. So I'm saying that my system will handle 20,000 requests per second, let's assume. Then that's the constraint that I'm putting on my system, that if anything crosses this boundary, my system will degrade or will not perform as expected. But as long as this limit is there, my system should perform well. So these are the two categories. And the major thing in a real world, which we don't get in an interview, is that once you have these requirements, you could take certain steps that would help you in your design process that we'll cover. So the first thing is making sure that you have crystal clear requirements from a functional standpoint. You have crystal clear requirements from a non-functional standpoint as well, because you cannot start designing a system that's meant to be handled for 100 people and suddenly have it handled for 10,000 or 100,000 users. It doesn't work that way. The second step would be doing capacity planning. But before doing capacity planning, you need to really think about your data structures. Because without your data structures, how are you defining the capacity? How are you defining the storage space or the network bandwidth that you would need? So you need to have an idea about the data structures you would have. From a user perspective, what are the basic functionalities that you want to handle, and what will be the amount of data you'll be sending per request? So number of requests, amount of data sent per request, the amount of data stored overall in the system. So these are things that in the real world you try to think about. And for capacity planning of these things, you need to have a good data structure defined. The next thing would be API design. If you go into API design, you're again thinking customer first. It should be a customer-centric approach where you're trying to think, what are the major functionalities that I have? How would a customer be interacting with me to fulfill those functional requirements, essentially? And basically, what is the data that the customer would be sending me? What is the response that I'll be sending to the customer? So this is from a functional standpoint. There are a lot of non-functional things. I don't know if I should call it non-functional, but which protocol you would use. So these are technical choices that you end up making in a real world system design. So which protocol would you use? Would you compress the data or not? Would you have a long lived connection or a short lived connection? So all of these are more of technical choices that you make as part of, it's not specifically API design, but associated with your APIs overall. After this, we could go into database design, and database is, again, a lot of options available to us within the database realm. And it's really important to make the right choice based on the kind of system that I'm trying to build. So one of the most common things we hear is the segregation between SQL and NoSQL. But within NoSQL umbrella itself, there are so many different options that you need to really choose the right technology that fits your need. And in most cases in the real world, there is no one need. There are multiple needs, and you don't have one single system that supports all of those needs.
Absolutely.
So that's where the real system design becomes challenging, because you have to leverage, you cannot leverage 10 different technologies because your stack becomes complex. Like one of the best things about, or one of the most important things to consider while doing a real system design is to make it as simple as possible. The more complex you make it, the more complex it is to maintain, the more complex it is to onboard new developers. There are all sorts of challenges if you go down that path. So it's easy in a system design interview context for us to choose 10 different technologies, but it doesn't work in the real world. So
Absolutely.
So the challenge there is to leverage or to choose a technology that fits most of your bills, and then try to optimize or try to leverage some of the things that are not really out of the box, try to build a solution for those. So there's some custom tweaking that you need to actually go and figure out or fix certain scenarios. So in the database design, choosing the right technology is one of the most important things. And then basically your schema design, how you will structure your data, all of these things come in. And again, these vary depending on the technologies that you're choosing. So a relational database design will be very different from what I'm doing in a NoSQL or a key value store.
Absolutely.
After this, we could go into a high-level design. And this is where we basically split our entire architecture into multiple components. We also incorporate external dependencies or dependencies that we have with other teams or other products of different companies. And we really need to think about how these different components interact, having a clear specification on how things are going to work together. So that's what we do in a component level design. Once we are good with all of this, we can go and deep dive into different components. And here, while diving into each component, you have to think about both the functional as well as the non-functional requirements. Because after you have done your functional and non-functional requirement, every design decision that you make henceforth is based on that. So even while deep diving into components, you need to think about what are the NFRs that you have guaranteed, what is the functionality that you need to build, and you need to build your architecture accordingly. In the real world, there are a lot more things that you build. So one of the things that I mentioned before was you want to keep it simple. The other thing is you want to keep it cost effective. I think 2 or 3 major things in real world system design: keeping it simple, building it according to the customer, making it customer centric. And the third one is basically this. So we need to ensure that our systems that we are actually building in the real world satisfy all of these things. It will be very difficult to manage systems otherwise. The other thing outside cost would be resiliency. So one of the when you're doing building blocks, it's easy to skip failure scenarios. But in a really good system design, you need to think about all the failure scenarios. You constantly need to think that something in your system would fail, and it can fail at any point in time. And the important thing from a customer perspective is to not have a long outage, is to be able to recover as fast as possible. So incorporating resiliency as part of your thought process during your system design is really, really important. And there could be a lot of things, like you could implement back pressure, rate limiting, recovery scenarios. One of the most difficult challenges is ensuring consistency in your data during outages. We could follow different spike mitigations. So like one of the most common things in interviews that I hear is, I will add X more servers to handle the load. In the real world, it doesn't work like that. Scaling up servers takes time, which means in the meantime, if your systems don't have a spike mitigation strategy, then it's likely that they will all go down, and then you're ready for an outage. So you have to think about these things in a real world system on how are you going to manage failure scenarios or unexpected load. So these things should be well thought through in a real world system design. One other thing is, if you're designing a distributed system, because you should be ready to have everything fail, your API should have retry mechanisms in place. And one of the most important things, and this comes up specifically while dealing with a lot of data, is idempotency. You cannot have a system that's dealing with data that is not idempotent. because
Absolutely.
if you need your distributed systems to be retriable, you need to think about if you retry a certain thing, it shouldn't change the state of your system in a way it shouldn't. So, and one of the things along with idempotency is idempotency window. Like you cannot have idempotency there for your system for an unlimited period of time. So you should be able to, if you are replaying certain things, you should only be able to replay 7 days worth of data. Otherwise, I'll give one example. I built a system that was basically a stream-based processing system. And in that system, basically, in case the end user loses some data, we have the ability to go back and replay the data. But if I give the capability of replaying the data from 1970, which means everything that I have, I will choke my system. So I cannot give a replay of 30 years or 40 years. I can only give 7 years, or it's not 7 years, 7 days or so. So this is basically something that we took as a design choice and then implemented my system according to that. So these are, again, real world requirements or basically constraints that I'm defining on my system, but it's extremely important to think about these edge cases.
Awesome. I think, so thanks for outlining like a general kind of a checklist or a framework, whatever we can call it, while we approach designing an application in real world, right? And as you said, there are so many different parameters that come into picture. And unlike a system design interview, which is like 45 minutes or 1 hour long, and you don't have those many constraints, you have slightly free hand and you can, try out things and,
Correct.
You just have to prove that you know some part of, different knowledge that you're sharing. Let's dive a little deeper into each of the points that you mentioned here, right? So I agree with saying that, it starts with the customer, because in most of the cases, whenever we are designing an application, right, if there is no customer, there is some user who is using your application, right? It may not be like a paying customer or something, but ultimately, whatever you are building impacts the customer. So starting with the customer makes a lot of sense, right? Because you're solving a problem for the customer. And if you're solving some problem that is disconnected from customer's problem, then you're wasting your time, right? So don't solve the problem that is non-existent, that is not helping your business to grow or helping your customer to get a better experience on your product. So, and one other point that you mentioned on requirements gathering, which is going to be the first thing that we can deep dive into, is so there are two types of requirements, functional and non-functional. And I think gathering these requirements is also like a responsibility of a developer or an architect, right? Because I've often seen sometimes we developers don't ask enough questions, right? Like, okay, there's a product manager, there is someone else who takes the decision. They come up with some functionality that they want to support in their product, but developers follow them and they don't ask a lot of questions to gather more and more details, right? And that's when most of the design or the decisions we are going to take in later point of time gets messed up, because you don't have so many information. You either make assumptions or you understand things incorrectly because you've not validated your understanding. So that is a very critical thing in real world system design. I think it is also related in system design interviews. If you don't understand the problem correctly, you're solving differently, not connected with the interviewer. So that is also there, but in real world, it has larger impact, because you might waste a lot of time, you might waste a lot of money, you might also create some negative customer impact. Great. Let's start with how do we gather the functional and non-functional requirements, right? So how do we make sure that we have the right set of requirements?
Sure. So I'll again go back to the thinking about the failure scenarios. For me, that's been the thing. I try to break the system as early as possible so that I know what my system is not supposed to do. Because you can know what your system is supposed to do from your product managers. But it's basically those as you said, misunderstandings or not getting the complete picture on what to build. That's where you go and you can have problems or basically misunderstanding, and you go building a wrong solution or something that wasn't really intended to be built. So for me, the first thing is I try to understand the requirements, and I try to ask or think about as many edge cases as possible to that requirement. Trying to identify if everything that has been mentioned in the requirement and all the pitfalls that could be there or all the corner cases that could be there are covered. Once I'm sure that I'm certain about the corner cases and I've handled most of them. Obviously, it's difficult to handle everything. You cannot. I don't think there is a possibility of covering everything, but in your capability, you should try and cover as much as possible. And this is one part where I think team involvement is extremely critical, because you and a single person could still miss something. Once you have 10 different people with 10 different perspectives trying to think in the same on the same problem statement, chances are they'll think in different directions, and that would highlight something that you missed. So during requirements gathering, it's extremely critical that your entire team comes together and approaches in a unified manner to solve the problem or get the problem statement correct.
Absolutely.
So that's on the functional requirement part. On the non-functional side, there are two things. I definitely prefer noting everything down as to we can estimate one basically based on a competitor's product or some other functionality that we have in our product that is serving a similar use case. So we can estimate our non-functional requirements based on that. Second is, one of the good habits to build is try and have alerts in your systems built upfront based on your NFRs that you have done in your design. Because the real world can actually differ from what you expected. You can expect a load, or let's assume you're building a cache and you expect a cache rate of 80%, but you're getting a cache rate of 20%. Obviously, it will impact your system. And this is where having metrics gives you a completely different insight and also allows you to course correct as soon as possible. So with NFRs, because it's an estimate, like everything that we are building or gathering in the requirements, it's an estimate. And the real world is going to be different. So it's important to actually think about it from that perspective as well. Just like we do story planning, we can say that it's 2 story points or 3 story points, but we end up taking a month. It's just wrong estimation. And it can happen in real world system design as well. It's important that we protect ourselves from it.
Absolutely. I think some important points that I totally agree with is, when you design a system, it's best to not design it, or at least gather the requirements, not in isolation, because there is a chance that you might miss a lot of edge cases. And it's all about teamwork. Like when we talk about real world, like our job, right? It's all working in a team. It's all collaborating. It's not individual. So we have titles called individual contributor, but it does not mean that you have to work individually in isolation. It's still, you have to work independently, but not in isolation. So you're still connected with the team. You're still, collaborating with them. You're doing the work that, helps them, and you also consume the work that they have done. So in that sense, teamwork is at top priority when it comes to, working on any problem that you want to solve. And yes, thinking about edge cases, like in the upfront, it makes a lot of sense, because again, I think it comes down to asking questions that, you assume that, oh, this is something that always works, but nothing can guarantee that it always works, right? For example, you receive a webhook from some API, and then you always assume that you'll always get a webhook, but that might not be the case. So think about a case when you might not get a webhook. You might not get a webhook at all, or you get a webhook, but in a delayed manner, like after 3 days. What do you do then, right? And then it's all about customer, right? So how, if the webhook comes after 3 days or in a delayed manner, how does it impact the customer?
Customer.
So again, all these things are tied together. And the more we work in a collaborative environment and in a way where we don't make any assumptions and think about all the failure modes that we possibly can, because we can't do everything. There will always some things here and there. And that's when, testing and, monitoring in production and playing with all these things comes into picture. So yes, observability, monitoring your system is really important. Even if, let's say, you are in a alpha or beta mode and you don't have so many customers, I think that's the right point to monitor things in production and figuring out all the problems that you can before going GA, because you might be impacting more and more customers. So don't stay in blind, don't stay in dark, have as many, points to understand your system better. And that will help you long way to also improve your design. And there is always incremental fashion that we work on a system design, right? It's because you have more time as compared to an interview. Also in interview, we have to work incremental, but we can talk about later. So it's all about extending your design, how you can add more and more layers, more and more functionality without changing the core part of it, because you don't want to keep changing your design every now and then, right? You want to extend it. So that is another point which makes a lot of sense. Cool. I think you shared some great points on, NFRs, where, how do you get those non-functional requirements? So functionality wise, okay, you want to give this feature to the customer. That is one functionality. This is like the user flow, how it looks like. But non-functional requirements are a little blurry. You don't have enough clarity. You have to make some calculations. You have to make some estimations. But the great point that you mentioned was to look at a reference architecture or reference application that is solving, right? So if you're designing a messaging application, why would you? Because there is WhatsApp already. But if you're designing a messaging application, look at WhatsApp. And if you aim to reach at some point at WhatsApp level, then there is a reference app, and how many messages are being sent and all that things will help you gather those non-functional requirements as well. So it's not about getting it perfectly right, because it's an estimate. That's why it is not accurate, but it's more about getting as close as possible to the reality. Let's talk a little bit more on these calculations, right? Like the capacity planning part of it. How do we, because we need some way to figure out these details. So what do we want to estimate? Like what are some things in your experience that you think make sense to estimate upfront?
So one of the most commonly used ones are storage. The other, and it depends on the type of system, but you can also have network bandwidth. If you have a really high traffic type of application, then you do want to think about the network traffic or the network bandwidth that you need to have to support, especially in cases of streaming services. So things like that. Outside this, you also can estimate your basically throughput of your system that you're expected to have. At a high level, you can define the latency that you want to hit, and then you could have your monitoring or observability to tell you the different percentiles of your latency that your application is actually hitting. But at a high level, these are the things that you would want to capture as part of your NFR.
Yeah, that makes sense. Yeah, I think, knowing how much storage you're going to need, and not only for 1 year, maybe a little bit more than that, because
you're as well,
you need some futuristic estimation as well to get it somewhere at a sweet spot and not being completely off. That I said 10 gigabytes, but I'm now needing like 10 terabytes or something. So being as close as possible, and also at a futuristic level, it's important. And like looking at the peak loads, because when you have like average loads right throughout the day, it's totally fine. But when you hit the peak loads, that's when things get a little messy, a little tricky. And so if you have those estimates that, okay, peak, I want to support 10,000 requests per second based on this, this, and this, like the calculation you have. So you can also test it that if you're actually able to support those peak loads and how long can you support those peak loads and all these kind of things. But also at the same time, we want to be realistic, right? So for example, you have a e-commerce application and you have a big sale on Black Friday or some festival. You say, okay, I'm going to get like 10,000 orders per minute. And that is the peak I want to support. So you don't want to hit your system 10,000 orders per minute for like 4 hours, right? That is not real testing because you're just burning money. So at the same time, you want to test the peak loads. Like, okay, if you want to have 10,000 orders per minute, go to that peak, look at what happens. If your system is fine, it's able to survive, it's fine. Not for longer durations, but because you're burning money, you're wasting some effort. But those peak times, how does it differ? How does it changes the state of your application? How failures interact and all that things? I think those are important. And of course, it will be driven by capacity planning. Like if you have some numbers from the business, it's best to get those numbers, maybe historical data, and you can just use some rate at which it can grow and figure out those details. So yes, I think taking those inputs as well and asking a lot of questions and being realistic at the same time is the way to go. Great. Let's talk a little bit more on how capacity planning can actually change your design decisions and how to take that input and pass it on to our actual design.
So I think one of the things that we already mentioned is capacity planning is an assumed guess, right?
Yeah.
So we need to start off by taking the reference, as we said, but then based on the capacity, we could take, like, let's take storage to begin with. So based on the storage estimates, I could decide whether I need to shard the data or not. Whether I need to be all on a single server. If I want to cache a certain percentage of the data, so I can calculate the total percentage. This is the percentage I want to cache. Is that cache going to be having too much data, or do I need it on a distributed cache versus I cache it on a single service, or basically each instance of my service? I could make those design choices based on the capacity estimations that I've done. And then there is a lot of optimizations as well based on the capacity planning that I do. So for example, let's take storage again. Let's assume that my capacity estimations come to around 1 terabyte or 5 terabyte. Storage is cheap, so 5 terabyte also doesn't cost much. But for the sake of discussion, let's say it costs a lot. It's similar to memory. So we can think about certain sort of tiered storage in such a scenario where for data that I don't need, I push it off to a less frequently accessed, more cheap storage system. For data that is more frequently accessed, I keep it on an active storage system. So these are things that are driven off the capacity planning. They are not directly induced, but I could conclude from the capacity that I have estimated that these are the decisions I could take that would help my system, or basically help me save costs. And I said cost is one of the major pillars in system design. So you would want to think about all of these optimizations such that your system runs in a cost-effective manner.
Absolutely. Like cost is such a big thing in real world that you don't even talk about in interviews. And cost is like one of the primary drivers. I think it sometimes is above the customer. I mean, because ultimately you want to, you don't want to burn money just to fulfill one customer's need, right? So you also want to save a little money. So it's also about, having a right balance between how much money you're burning and how much benefit you're getting in terms of customer impact. So, and I think we have jobs as far as our product is, sustainable from the business perspective. And if it's not sustainable, we are going to lose our job. So it's our job as an engineer to save cost for the team, for the org, for the entire company, and make a positive impact there. So yes, cost is a huge thing, and we should plan for it. And we can only make some guesses or estimations, but it can always be improved, right? So because once you have data in production, once you get those metrics, okay, maybe my disk usage is not that much, so I don't need this much disk, right?
Yes.
This can be one. I don't need such powerful machines because I'm not getting such load or things like that. One point that you mentioned about tiered storage, I think tiered storage is evolving when it comes to systems that natively support tiered storage, that you can just configure certain things and you get tiered storage out of the box. That is beautiful because that is so cost effective. But if your technology don't support tiered storage, that is a very great way of saving money, because keeping everything in hot storage, as in SSDs, might be costly.
Correct.
You can move it to something like S3 or maybe Glacier or whatever that is cold storage, which is not accessed frequently, and you can save a lot of money actually, right? So that is a great way to think about, possibly right from the beginning, but at least once you have some metrics around that, think about how you want to offload your data to a less costly or cost-effective storage. Great, that makes sense. And
one
I think
thing that I think we could also add is, it could also help you make performance optimizations. If based on the metrics you see that you plan to cache, but in the cache itself you could also leverage CDN. CDN is expensive to use, so that's why your capacity estimations are going to be really critical. You don't want to overload or put a lot of data in the CDN because it will again cost you. But this again, capacity estimation can help you see if you can make good use of CDN and what type of data you want to put there.
Absolutely. I think it makes sense, and it's again best to think about all these things upfront, because you don't have to deal with it later when there is a problem. Because when something is burning, your mind doesn't work. There is so much pressure and deadlines and all that, so it's hard to prioritize, and that's when the work-life balance and all that gets a little tricky. So we keep complaining about work-life balance as an engineer, but I think somewhere we are also responsible for that, right?
It's the karma.
It is the karma, but that's a different podcast, maybe next time. Great. I think there is one more requirement that I think I would add from my side, and these days it is becoming more and more relevant, that thinking about the geo distribution of your data, right? Since we are talking about estimations and storing data, I've seen so many compliance related things, GDPR related issues, that a customer wants their data to be confined within, let's say, a country, the boundaries of a country, right? So you have to plan accordingly as well. So, and it starts with right from what you're storing in the database. So for example, you're storing in a database some customer related data, but you don't store, let's say, the location or the primary or preferred location for that customer data. Then it might be a pain to move that data or to migrate that data to a certain location, right? So thinking about this in that terms, if it's relevant for your application, I think that helps a lot. So you don't have those migration pains where you scan a lot of tables, you figure out using or hitting some other service, okay, what is the location for this customer, and then migrate that data. So instead of that, thinking about geo distribution right from the beginning, I think it will help. Just storing some identifiers and then estimating your number of servers, storage, and all that in particular areas, because not all areas might have those many available servers when you need it, right? Because cloud providers also have some limitations. Of course, it is cloud, but it's hidden from you, but there are some limitations in the background. So it's best to estimate. And these estimations, I think, play a critical role when you have to support some big events like a Black Friday, right? So you can say, okay, I am going to need like 100 servers, but maybe if I need 200, I can scale up. No, because it's a Black Friday. Even Amazon is busy. They might not have servers that you want. So it's
Correct.
best to do that capacity planning, requirements gathering, and pre-scale your application, right? Because that is also important. You can't just say, okay, I was wrong by, let's say, 200%. That's not going to work. It's a little awkward to do that. Great. I think moving on. Yeah, sorry.
One thing that I would like to extend there, like just like you said, like handling special occasions. The other thing is, like, we talked about iterative development in real world system design. And when you do iterative development, you actually have to go back and revisit your capacity estimations. Let's suppose you're adding new features and you're adding new tables to support that feature.
Yeah.
You will incur extra storage, and you cannot just rely on the same storage that you have already to
Absolutely.
be able to cater to both the additional and the existing requirement. So you have to
Absolutely.
think about system design. If you're doing an iterative model, then make sure that you go back and revisit the capacity estimations that you have done already.
It's a feedback loop, right? Like
Yes.
Like it's the same feedback that you get from your manager, and that sometimes people ignore, but it's best to address that feedback and try to feed in your next cycle.
Yes.
So similarly, for your system, you get some feedback from your customers, from your metrics, from incidents that you have, from business people. You need to get that feedback and pass it on to the application and make some design improvements, right?
Correct.
So you don't want to repeat that mistake, because repeating mistake is again costly. It's bad for customer experience. So it's a cycle. It's never ending process, and you have to keep. That's why I said initially, there's no perfect system design. There's always bad and less bad. So yes, I think that's a important point. A lot more important in real world than in 45 minutes interview. So great. Let's move on to the next point, which is choosing the right tech stack. This is kind of my favorite one, because you are never able to choose that right tech that you really want to work on. And there are so many other parameters that dictate what can you, how much of a free hand do you have, right? So what is in your experience works well when it comes to choosing the right tech for the right problem?
So for me, like, there are a few parallels that I draw. I think I can talk about that for an instance. So, like, in real world programming, we have the open close principle. You said that we do iterative system design. When you're doing iterative system design, you would want to keep your system extensible and have less or no changes if possible, but as little amount of changes as possible in your existing system design.
Yeah.
And then the second one is divide and conquer. Like, when you're doing system design, you would want to break your system into different components, conquer them, and then you see the merged result at the end. While doing or how to choose the right technology, this also draws parallel from a real world where there's no one. It's just like a choice, any choice you make in life. Like, there will always be a trade-off associated. If you're trying to choose between two houses, because I'm house hunting right now, so I can tell that, you will always have some feature or the other missing in one house, but present in the other, and present in one house and missing in the other. And
absolutely,
you need to make a call on what fits your bill to the best possible extent. And choosing the right technology, I think, is exactly that. Like, it's about choosing a technology that fits most of your bill. If it fits your requirement 100%, best case scenario. But in real world, chances are it won't happen like that. So you have to think about the trade-offs of different technologies and which trade-off are you willing to take. So that's extremely critical. And how do you choose? And as you said, there are a lot of external factors. Like, you could be restricted by, like, your technology might be a company-driven technology. Like, this is what your company as a whole wants to use. You don't want to go to a competitor or some other technology. That's one thing. The other could be the proficiency of your team itself. Like most of your team might be proficient in Java. You don't want to use some other programming language. So this is more of a programming language example, but it can be extended to actual technologies as well. So there are a lot of external factors, but I think while choosing the right technology, after applying all these constraints, there are a few things that you need to keep in mind to choose the right technology. One, again, I'll repeat, is cost. And the second one is maintainability. Maintainability is almost often ignored, but I think the work-life balance aspect that you talk about, that comes, you'll have a better work-life balance if you think about maintainability upfront. Otherwise, it will be a nightmare. When you're using open source technologies, you really have to think about the maturity, especially if you have an enterprise grade product or if you have a large scale system. You really have to think about the maturity of the open source system that you're using, the community support that you have. All of these things become extremely critical while choosing a technology that you want to use in your system. So basically, the trade-offs that we are considering could be depending on the technology that we are looking at. But for me, I always end up choosing the thing that has these two factors of cost and maintainability sorted. If these two factors are sorted and it satisfies all the other things that we mentioned before, the company agrees to that, people in my team are proficient or have no problem with that, then I would be able to choose a particular technology where I have to give the least amount of trade-off, which satisfies most of my criteria, so I can go with that.
Absolutely. I think it makes sense because in real world, as you said, there are so many restrictions, and these restrictions are there for the right reasons, right? Because one can go a little personal and think about, okay, this is a cool technology, I haven't worked on this, and it would be really amazing if I add it on my resume. But that is not going to work for certain situations, right? As you said, it might be costly. There might be no experience in that technology in your company. It might not be like a community driven technology that you might have support outside of your organization, right? If you leave your organization, then no one else knows that technology. So all these kind of sort of hidden criterias are there, always there. And as a leader, as a senior engineer, as an architect, you have to remove those personal aspirations and think about the customer, the team, and the company, and all that before you can think about what you want to do personally, right? And keeping that in front of all these decisions that you make, I think it will definitely help you in your career to make good decisions. Apart from that, let's say all those things are in your favor. You have the money, you have enough experience. Then it comes to your ability to convince people, right? And convincing the right way, not convincing as in giving them money or something, okay? But it's more about talking about the type of solution, or the what are the good things, the pros and cons of this technology, and how it compares with other options that you have, right? And then talking again, team collaboration, working with the team, finding a solution that is right for the customer and the company in a together manner. So I think that comes into the picture. And I think somewhere which is kind of inherent to all this discussion is the understanding of the technology, right? If you don't understand certain technology, you won't understand pros and cons. So if you have to really make that decision, if you're at a position that you want to make this decision, you need to understand the technology in depth. Otherwise, making those decisions might bite you back after, let's say, 1 year, 2 years, when you reach that limit of that certain technology, right? So how it scales, how it fails, how it performs at peak loads, how it performs in an average manner, how the cost grows with growing data, and all that things, right? And of course, the most important point that you mentioned is maintainability. Like how easy it is to maintain, and how many on-call pages it is going to create just because it is not maintainable. You don't have visibility into that. So support of a technology is not just a piece of software. It also ecosystem that is around it, right? If you don't have good ecosystem, that is people who are supporting it, enough experience, right tools to automate that and monitor that, and making it less painful for you. So I think these are really important while choosing a right tech stack, and not just, okay, I want to use Java, I want to use Scala, I want to use Kafka, whatever. But think about the core problem at hand, and not give the personal aspirations more important than your customer and company. Since we are talking about the trade-offs, let's also so whatever trade-offs we make, right? We base them on certain criterias. That okay, for me this thing I can trade off. I don't really need this quality of this service, right? And then ultimately, in real world at least, it is tied back to the customer. Like how this trade-off that I'm making, or the choice that I'm making, related to anything, not just choosing the technology, but implementing certain let's say failure mechanism. How many times do you want to retry? How many for how many days you want to retry a certain event, for example? For how much duration you want to support the idempotency for, as you talked about the idempotency window. So all these trade-offs that you're making between cost, speed, performance, throughput, whatever, I think it ties back to the customer. So what is in your experience has worked for you in making those customer use case driven trade-offs?
So I think it's more of reverse engineering. So you go back to the functional requirement, you understand what the customer critically needs, and then you reverse engineer from there to see if the trade-off you're making aligns with the functional and the non-functional requirement that you had defined for your system. If you don't go that way, and if you just do it in a silo, chances are you will again be re-architecting and there'll be a huge cost again.
Absolutely.
So any design decision that we make, so simple thing as you mentioned, we can add to that like push and pull notifications, whether you want to go for a pull mechanism or a push mechanism. It looks like a tech different choice, but it ultimately has an impact on customer experience. One of the most common ones are whether we choose a strongly consistent or eventually consistent database. It has an impact on what the customer sees immediately. How consistent is the data if he's viewing from different regions, or if there are multiple customers viewing the data from different regions. So all of these are basically driven off the requirements that we had defined initially, that, okay, it's okay for the customer to see the data with certain delay. There could be a latency involved. Internals of the system as well. So whether a system is choosing, whether you're choosing a system to be highly available through replication, or whether there's a consensus protocol. In case of a consensus, you will always have higher latency, and you cannot guarantee the response that you're sending back. It could be a very old response as well, because all the systems just need to have a consensus on it. They don't guarantee correctness. So these are the choices of based on our choices, ultimately the customer is impacted. So it's best to go the other way around and start off with the customer, think about the customer first, and then see if the system that you're choosing, the technology that you're choosing, if how it works internally satisfies what you have chosen as part of your functional and non-functional requirements. And only if it does, go ahead with the technology. Otherwise, it's not the right technology for your use case.
Absolutely. I think it boils down to, starting with the customer and starting with the user, like how the particular user will see that behavior and consume that behavior, and how does it impact the user that depends on your product, right? So just to add one example there, just to make it a little concrete, from my experience, that I work a lot on messaging apps and all these communication applications. So for a certain message, let's say your message arrives in a pipeline and you want to send that to like a third party, and it fails, right? So how many times do you retry? or how much time do you keep retrying, right? Like, let's say for a day, for 2 days, for 3 days, you can choose to retry forever until it succeeds. But then if you think about the customer, right, it depends on the type of message he or she is sending, right? If it's like let's say it's a notification, which is it only makes sense for a Black Friday event, that, oh, here is your, discount, which only works today. If you keep retrying that message for 3 days and you end up sending that message to the end user after Black Friday is over, it is a bad customer experience, right?
Yes.
So the trade-off you're making between how many times you want to retry versus dropping that message on the floor because you're failing depends a lot on the use case. For some, it might be few seconds. That, let's say you want to send an OTP message, right? OTP is, let's assume that it is only valid till 15 minutes. So you can't send that OTP after 2 days. I mean, you might end up sending depending on the failure modes in your application, but the obvious choice, or the conscious choice that you make, it should depend on their use case.
Correct.
So, and there are so many decisions like that you have to make every day in your job. And the better you understand your customer and their use case, the better decisions you will make. That's for sure. So, great. So I think it makes sense to follow a general guideline, thinking about the customers, thinking about the high level estimations, and making your system extensible and not a lot of modifications every few weeks, and then understanding the trade-offs and translating it into customer impact. I think overall this is something what we have discussed so far, and I think it is extremely helpful for young engineers who are who want to get better at real jobs and grow in their careers and design better systems for the customers. Anything that I missed during the summary part of it, or anything you want to add there, feel free to do that.
No, I think the highlight from what we discussed is how to leverage the initial choices that you have made. And
yes,
you have to understand that it's all connected. Every decision that you make after functional and non-functional, it has to be driven off that. So whether it's design choices, technology choices, type of database, the API you will design, each and everything is connected to that particular piece of information that you have gathered in the beginning. And hence it's extremely critical to do that very well.
Yeah, absolutely. Great. So I think we have talked a lot about, real system design and how it applies, or how all these principles may apply and help you in your job. Let's give it a little flavor from the interview's perspective, right? Because you can only apply the real world system design principle if you have a job. And for the job, you want to implement these patterns or, ideas in an interview. So let's talk a bit about how the general framework that we just talked about, how it is implemented in an interview, and what are the differences between an interview and a real world system design framework.
Sure. So we can leverage a lot of what we talked about and in the framework in a system design as well. The only thing is it comes with a very restricted context, because you just have 45 minutes. You cannot in reality cover everything. And one of the most important things is, in a system design interview, you need to be time bound. You cannot keep discussing functional requirements and get to the nitty gritty of the requirements and take 25 minutes in it. That's not going to work in a real world system design interview. So when we talk about, let's go over the same framework that we talked about, and then we'll highlight where the differences lie in a system design interview. So we'll start off with requirement gathering. And in requirement gathering, the functional requirement part is more about scoping the problem that you're trying to solve. So if you're trying to design an Instagram app, Instagram has got a lot of features. It's messaging, it's photo sharing, it's reels. You cannot cover everything. So for you, in a system design context, functional requirements is basically you trying to get to or ask the interviewer or gain a consensus with the interviewer on what is the specific problem area that you're looking at. So scoping your problem statement is the requirement of doing requirement gathering or functional requirement gathering in a system design interview context. Non-functional at a high level remains the same, but then we really don't talk about how are you going to achieve 200,000 requests per second, or how are you going to achieve X non-functional requirement or constraint that you have defined. So NFR continues to be constraint in your system, but you're not really, it's more of to see how you're going to translate the NFRs into your actual system design. Like whether you choose the technologies, whether you're choosing the components or building the components in a way that you end up satisfying the NFRs that you have defined early on. So from these two aspects, it should be the same. One of the things that I've seen in system design is people go on to capacity planning after this, but without they just say no from the NFR that there'll be 100,000 requests and there will be 1 million users, and they assume that the data will be 10 GB. But there's no relation to how that 10 GB came. So it's just a number out of the air, and it's extremely critical to define the data structure in an interview before you go into capacity planning. So once you define the data structure, you should actually try to do a back of the envelope calculation to see the amount of data that you are going to be storing. And then one of the things that I like to see while I'm interviewing is people leveraging that information to make further design choices. Again, if it's a disconnected thing, like someone said that they will be having to store 1 GB of data, but then they are using a non-relational database, or they're using a database in a clustered mode. I don't understand that. For the amount of data, you might as well just use in-memory cache. It will be much faster. Why do you want to go to a disk-based storage? So basically, your framework still follows capacity planning, but to do capacity planning, leverage or understand the data structure that you will have to store the data such that your functional requirements are catered to, and then based on that, do capacity planning. API design, in most system design interviews, you would just define the high-level API, you would define the request response codes, you would define what are the parameters that you're expecting, what are the parameters that you are, or basically what is the response that you are sending as part of your API request. And then one of the things that I recommend people do is talk a little bit about authentication, API versioning, because that is something that in a real world system design you would generally have. So it shows that you think about those things, because versioning is something that I most often see people skip, and that's something that I prefer if people don't. We can then go into database design, and this is one area where I see people struggle the most, choosing the right database technology. And I think it should be you need to understand the framework underneath the different database systems, and then choose your database based on the framework. So each database, as we said, each technology has a trade-off, has a pro and a con. You need to understand how that technology works, what are the pros and cons associated with it, and then make that database design choice. NoSQL is a blanket, and a lot of times that blanket is leveraged. SQL has become highly unpopular for some reason, which I don't agree with, because I've seen extremely large scale systems run on SQL. And so people really need to think about why they are choosing one technology over the other. And it's these design discussions that, from an interviewer perspective, it tells me a lot about the candidate. It tells me how they think, how much they like to research, how much they know. So it's while talking about, we are still talking about the framework, but these are things that from an interviewer perspective, I would think about. After this, you would go into a component design or a high level design. This is basically something that everyone does, multiple block diagrams or blocks each connected to each other. one thing that I would say for component design is you really have to think about the components you're trying. Like, does your system really need an API gateway? Does your system need a cache? Just because you have seen it in some architecture diagram somewhere doesn't mean that it warrants that specific requirement. So we need to really think about what we are conveying in a system design interview. And then in the end, you basically deep dive into one component, basically. You don't even deep dive into multiple components because you won't have the time. But if you do have the time, you would talk about how a particular system is going to function, how it interacts. So you talk about one particular service and you take it or you explain things from that perspective. And it's best if you talk the component that you're talking about is core to the functionality. I don't want to talk about how API gateway is going to function if that's not the core functionality of my system. So in a system design interview context, you should talk about the core functionality that you're trying to build and deep dive into that.
Absolutely. I think I agree with all the points that you mentioned, and I have kind of similar experience while I interview people, and based on the mistakes I have done while interviewing in the companies, that I often miss out. So system design interviews are also meant to be, have these behavioral aspect to it, right?
Yes.
So as we talked a lot about, team collaboration, teamwork. So I think what I often see missing is the right behavior for the system design, right? Because that is extremely, extremely critical when it comes to the real world job. So in the interview, who you have is, let's say, a couple of interviewers or 3 interviewers if there is a panel. So you should work along with them, right? And not work in isolation. As we talked about, like, even if you're an individual contributor, independently, you have to work on that, but you don't have to work in isolation. Don't assume things, ask a lot of questions, don't jump, make them incremental. And all the things that we discussed in real world system design, I think applies to system design interviews as well. One important thing is thinking about the customers first.
Yes.
Because most of the companies, like majority of the companies, the interviews that they design is mainly meant to see how well you fit. If they give you the job and you have to design similar system in a similar environment, right? And how do you make those decisions? So if your decisions are totally based on customers' use case, that will add a lot of value. And that will also give you a lot of clarity, right? Because you're not making some random decisions. It's totally based on the source of, the problem. The source of the problem is customer, because he has a lot of problem. He or she has a lot of problems. So you want to solve that. So work in a team with your interviewer. Don't work in isolation. Communicate, right? Communicate your ideas. Communicate why you're choosing certain technology versus why you're having a cache. Why do you use this database? How long you will store the data, and how will the flow look like? If you're working on API design, I think that's a great entry point for diving deep into the interviews, because APIs are used by your users and customers, right? And if you start with the API, you are kind of defining the contract of your system, that how someone can interact with your system. And a lot of that unknowns can be figured out. If you want to have a synchronous API versus reporting style or an asynchronous style of API, again, that ties back to customer impact and customer use case. And then you can make those estimations, like what kind of API do you want to use. Don't go too deep into the tech part of it. Like, okay, I would go with REST API. If you say that, it's okay, but you need to have some reasoning behind, okay, why did you say REST API? Just because it is popular? No, because this is the user and it's simple to use, like REST API. It gels very well with different stack and whatnot. If you choose a certain database, as you mentioned, have a reasoning, because they also they just don't want your judgments. Okay, let's go with Cassandra. They also want some reasoning, and don't say I will use Cassandra, but talk about the reasoning. Okay, I might use this database because I want this and this feature, and maybe Cassandra suits well because this also supports this. So they want to see how you flow through ideas and make those decisions and conscious decisions, and not just throw some random buzzwords or tech at the interviewer, right? Because most probably, in most cases, the interviewer already knows one design, right? And if you're really off that design, it's maybe not going to work. So take those inputs from the interviewer and make the decisions while you follow this framework or checklist, because this is going to give you a very incremental approach. So yes, I totally agree. I have the same experience. Don't jump on solutions. Don't come up with a baggage of already known solutions, because that is not going to help. Solve the problem right there and be there, be present with the interviewer and not be somewhere in your own mental space.
Correct.
Great. Anything to add there, or maybe we can move to the next part of it?
Yeah. So just one thing, like I completely agree with everything that you mentioned. And I think a lot of what you talked about also translates to the real world, right? So
absolutely,
a lot of people think that 45 minutes is too less to judge or to have a system design interview. But it's a lot about trying to understand how a person functions from a behavioral aspect. It's basically discussing with your team. Like I had mentioned somewhere that best interviews are where you have a discussion with the interviewer. So
yes,
it shouldn't feel like an interview. If you are communicating ideas, if you are bouncing off each other's ideas, then that's the best kind of an interview. And that's basically teamwork. So it's basically showing, if put in a certain environment, how you would function. So the behavioral side of thing, often ignored, actually plays a very critical role in interviews like system design.
absolutely.
Completely agree with that.
Absolutely, yeah. So I think the core idea is to not disconnect your interviews with the real world. And that will answer your question. How do you prepare for system design interviews, right? Because it is not disconnected. It is the actual system design that you have to do in your daily job. So take it seriously. If you have a job, take that job seriously first, and then you will get better eventually. Great. Moving on to the next section. So I think we have already discussed a lot on how it differs from the real world. What components should we include? But what are the components that are must have in a system design interview, right? So of course there are like endless number of things that you can talk about, but unfortunately you only have 45 minutes. Fortunately or unfortunately, that will be decided. But you have less time. So how do you get that list of basic things that are must-haves?
So, like in this aspect, I don't think there is a must-have component in system design. Must-have component, like I've seen in a lot of interviews, like an API gateway or a load balancer or a cache, something comes by default, but it's not really needed. Everything in a system design interview ideally should be based on just your requirements. So if it suits the requirement, it's a component that's needed. If it doesn't suit the requirement, then it's a component that's not needed.
Not needed.
It's extremely critical to not have preconceived architectures and then use that in interviews, because the same question can actually be having multiple different architectures just based on a change in requirements. So like, I could have a design Instagram where instead of talking of a photo upload service, I just talk about the commenting aspect of it. And my design, if I'm looking at just from a comments perspective or likes perspective or reactions perspective, will be completely different from the design I have for Instagram from an image upload and image sharing perspective.
Absolutely.
So it's really important to not go into a system design interview having any components as fixed or any fixed design in mind for any system that you have. And this is the example that I gave is still change in requirements. I could have the same requirement, but I could change my NFRs. And if I change my NFRs, my again design itself would change. Like system design for Instagram is assuming it to be eventually consistent. If I make it strongly consistent, the design changes completely. So you cannot go into, or you should not go into a system design assuming certain components or trying to reproduce something that you have learned before in a system design interview context.
Absolutely. So yes, don't go with any baggage. Go with only ideas, right?
Correct.
And use those ideas to design solutions right there, and not just blabber about some existing solution. And must-have components. Of course, there are no certain must-have things that you need to talk about in interviews, but at least if you have, let's say, 45 minutes, if you're stuck, if you have no idea what's going on, yeah, right, at least talk about the use cases, the basic flows.
Correct.
Because as interviewers, once you take an interview, you are collecting some data points about the interviewee, right? And then you have to fill up some scorecard, and based on that, you don't know that if you might do really well according to you, but you might not give any data points to the interviewer.
Correct.
And you may do not so well, like average, but you may end up giving so many great data points about yourself, and that may add a lot of weightage to the decisions that an interviewer makes. So I think it's the responsibility of the person, of the interviewee, to actually give those data points, to actually drive the interviews without being dominating, right?
Correct.
That I want to design this, I don't care what you think about
In my way.
But yeah, my way or highway. So it's not like that, but in some way you want to drive the interview flow and give enough data points about yourself, about what what you can do, how you think, and all these things matter. So don't take this as a disconnected world. So interview is not just filter. It's a lot to do with the real world job, if you get the job. So to get the job, do well in your interviews, and keep these two things connected, and you will automatically do way better than you would if you take interviews as a disconnected thing totally from the real world, right? Let's talk about the last question, which is the most important ones. I've seen a lot of people, asking these questions to n number of people on LinkedIn, on Twitter, and it's so important. Like, how do I prepare for system design interviews? And a connected question is, how do I get, better at system design interviews?
Sure. So I'll start off with the first part. How do I prepare for a system design interview? One of the most common resources used are YouTube videos. There's a plethora of them, and good YouTube videos from great instructors talking about how to design a certain system. It's got one caveat though. In none of those videos there is cross questioning. So it's more like I am choosing this technology because of XYZ. But in the real world, the interviewer might still, why not some other technology? Or it might be a twisted requirement where whatever the decision the other person made in the YouTube video doesn't apply anymore. So
yes,
it's YouTube videos can be used as a resource, but the advice I'll give is use it as a reference. So try and solve the question yourself. Compare your solution with the solution given in the YouTube video. Second is, at each design choice that is made, at every decision point, scream why. Why this? Why not that? What is the trade-off of choosing this versus that? You need to be crystal clear on every aspect of your design. Just like we say that if you put something on your resume, you should know that very well. It's the same thing. If you put something on the system design board, you should know why you're doing it and what is the advantage as well as the disadvantage of doing it.
Absolutely.
It's not just the advantage or the reason for choosing a certain thing. You should know the drawbacks. You should know the limitations of choosing a certain technology or choosing a certain component and how it impacts your design. If you don't know that, that is where your system design interviews don't go as well as expected.
Absolutely.
So
I think that is a great point. And I have some similar recommendation. Like first recommendation is the same that I talked about in the last section, that don't think system design interviews are disconnected from the real world system design. So if you have any system that you're working at, it doesn't matter how low scale it is, how basic it is. Think about it from a perspective of what can you do better, and implement those patterns. At least if you're not able to implement, at least try to implement like a logical solution for that, right? And try to learn from the existing system that you work on. People
yes,
keep saying, I don't work at a company that has high scale. It's fine, but at least what you have, at least gather that, right? Because you have something, you are serving real customers, so at least get some behavioral aspects, some the non-functional requirements, functional requirements, API side. At least take those pointers and learn from it, right? That is the first step. And of course, don't take any video, anything on YouTube, any course that you go you take. Don't take it as a spoon feeding mechanism. It's not going to work. It's always based on the context. So have, as you said, ask those why questions. Even if there is an expert in front of you explaining something to you that this is the way to do it, ask that why question. Be curious about the things that you're listening, hearing, doing. And the more curious you are, the more questions, the why style questions you will ask. The more why style questions you ask, the more answers you will get, the more insights you will get. So ask those why questions. Don't be settled for certain design, certain video. Oh, this is a great course, let's take it. It will give you a great insights. It will give you a great starting point, but that's not it. You have to keep learning, because tech space is changing a lot. There are always new patterns. There's so much research going on. So it's not that this is the silver bullet, take this video, go for it, and you're done. You're done with system design. And don't stop only at the interviews. Keep learning. So
yes,
you never know, you might have to apply for another interview. Just joking. But those knowledge can also be implemented in real world. So these are the recommendations from my side that I typically give to people. This reminds me of one thing that I totally missed, that people keep asking, I don't have experience in system design, right? So how do we get better, or what do you recommend to gain that experience, right?
So I think I'll start from what you were suggesting just now. If you want to get experience in system design, start with your own system. You're already working somewhere. You're already working on a product that's catering to customer. The scale doesn't matter, but it's still a system and it still has an architecture. Learn about the architecture. Learn about the trade-offs that were made for that architecture. Learn about the technology choices that were made and why certain technologies choices were used over the other. So all of these are important questions to ask. And so like, let's say I'm someone who's been working at a company for 5-6 years. Chances are I'll take that architecture for granted. Like, this is how it's supposed to be. But when you start asking these questions, you also identify areas of improvements. So before going into areas of improvement, I would say start involving yourself in design discussions. So make sure that you are part of the design discussions, even if you're not actively contributing. You get a lot by just being curious and being open to the ideas around you. So if you're actively listening, you would still gain a lot. And once you have all of that, then if you have identified areas of improvements in your system, try and architect those. So start small. You don't have to architect an entire system. You can architect a feature and then you can build from that. So with each step that you take, you would get feedback, you would get experience of what you have done well, what you have not done well, where you can improve. And that is extremely critical, because no one becomes as you said, we're still evolving. There are a lot of mistakes that I will still make in my designs today that I will rectify as I go along in my career. So it's an ever evolving process. So it's important to treat it that way, and it's important to, like, when I did my first system design, I wanted to be perfect, and for that, I made sure that I cover as many failure scenarios and think about all the edge cases and all of those things. But there's still a lot that I gained after implementing that as well. There are a lot of things that I missed. Once you start doing that, you will realize that there is a lot to do in system design. So we talked about good observability, monitoring. There is networking. There is a lot of internal concepts in networking that you get to learn. So there are a lot of things that you have to cover, and it's impossible to do that in 6 months or a year. It's a career that you have to build, and it takes a long time.
Yeah, makes sense. So don't take shortcuts.
Don't take shortcuts. Yes.
That's the crux of what you said. Great. I think we have covered a lot. We have covered a lot of insights, and I'm sure it is going to help our viewers, especially the young people who are confused, because there are so many resources, so many things to do. And what we have shared today is just some guidelines and our experience with system design, and kind of destroyed some of the myths around it. Let's leave our viewers with some resources, because of course we also learn every day. We do some things. So what are the resources that you would recommend to folks out there?
So I'll start off with high scalability. That's where I had started. Actually, even before high scalability, I started off with AWS white papers. So when I started my journey into the cloud, I came around AWS white papers and I started reading those. So that's my first entry, and then highscalability.com. And post that, there have been a lot of blogs, and there's so much content out there. Like, if you follow engineering blogs of big tech companies like Netflix, Meta, there is a lot of Uber. There's a lot of good content. Uber has a lot of good systems that have been built from the scratch, and they've shared almost everything around it from an architecture level. So those are very good. So leverage those engineering blogs. I would say talking to people, that also expands your horizon a lot. People that are senior to me, that have seen a lot more than me, can give me so much insight without having me go through that process. I can gain a lot from them. So I think that's an aspect that probably would be not appreciated as much, but definitely my seniors have taught me a lot, and I continue learning from them.
Absolutely. Yes, I think that these are also my recommendations. I don't remember if you also recommended InfoQ, but I also find that very very useful, because they have some great speakers out there. They have blogs, also have podcasts, like if you only like the audio versions. So there are some great speakers out there. There are some great tech talks. So I also recommend a lot of white papers. So if you want to go deep into certain technology, and not just the understanding of technologies, because white papers might be missing some of the latest features, because it was, of course, white paper, it was launched a few years ago, but it will give you the design choices and the design decisions and the trade-offs that they have made, right? So that is a great way to understand those. So don't miss on white papers. Reading books, right, I really recommend it. Nowadays, we don't have high attention span, so we end up consuming resources that are quick enough to consume while you're just walking your dog or something. But read books, and try to implement the knowledge as well. Another one that you said, I completely agree. I do that a lot. Talk to people who are interested, who are like-minded, who want to talk about technology in depth. And that is the reason I also do this podcast, because I learn a lot from people, from our guests. So yes, that helps a lot. It's my personal experience as well. And yes, keep that curiosity. Like, as an engineer, it's your responsibility to always be curious and a little lazy, so you automate things and not go with the manual process. So yes, I think we have covered a lot of depth, and breadth and everything that relates to system design in real world, and also compared it with the system design interviews. So I'm pretty sure that it is going to be a lot insightful for our viewers. Did we miss anything from your perspective, or I think we are good?
One thing or one suggestion that I'd like to give is understand the pattern behind different technologies. That's
Yes.
a critical aspect, because there are so many technologies out there. It's difficult to know each and every one. But if you understand how things work internally at a high level, you could relate, or you could jump from one technology to other. The similar concept to programming language. If you know C++, you can jump to Java.
Yes.
Just some syntactical issues, but the core object-oriented programming concepts remain the same. Similar thing we need to leverage. So, one LSM-based data structure or database, you could jump to another one, and internally it would work the same. Your abstractions might be different, but you need to think about, or
Yes.
you need to identify patterns, and then you need to learn or basically apply them while you're switching between technologies.
Absolutely. +1 on that. I mean, always understand patterns. Don't, focus only on implementations, because implementations may change over time. The high level patterns remain the same. So yes, totally recommend that as well. Great. So thanks a lot, Pratik, for, sharing all the experience, talking to me about system design, destroying some of the myths. This is kind of a hot topic out there, because so many people have those myths, and they want to get better at system design interviews, but that's not the right way. Get better at system design in general, and you will do well in interviews. So thanks a lot for joining me today, and I also hope that you also enjoyed the discussion, and I'm sure that this is going to add a lot of value to our viewers.
Cool. Thank you so much, Cavalier, for having me, and I loved the entire discussion.
Awesome. Thank you.
Thank you.